Hello, welcome all. Welcome to video 4. My name is Kunal and we are now going to talk about exam section 2, data processing. In this particular section, we will talk about exploring data, handling missing values, encoding features, and preparing your data for the modeling. This is classic data science fundamentals, but the exam actually tests Databricks specific approaches. So let's start. We'll start with how to explore and summarize your data on Databricks platform. Let's start with summary statistics on Spark data frames. The exam actually tests two approaches for computing summary statistics. First one is df.summary. This method actually returns count, mean, standard deviation, mean and max, but it also includes 25th, 50th and 75th percentile. This makes it more comprehensive than df.describe, which only gives you the count, mean, standard deviation, mean and max without the percentiles. Remember this distinction. The exam might ask which method provides quartile information. Second is dbutils.data.summarize. This is Databricks specific. It generates an interactive visual profile of your data frame, showing distributions as histograms, missing value counts, data type information, and basic statistics. It is the fastest way to get a visual overview of your data. Use both of these to understand your feature distributions before you actually start the modeling. Understanding your data is the foundation of every good ML pipeline. Now let's talk about removing outliers. The exam tests two methods for outlier removal. The standard deviation method, which removes rows where a value is more than k standard deviations from the mean. Typically, k is 3, meaning you keep values within the 3 standard deviations. This works well when your data is normally distributed. The second is inter-quartile range method or IQR method, which is more robust. You compute first quartile, that is the 25th percentile, then the third quartile, which is the 75th percentile, and your interquartile range or IQR equals Q3 minus Q1. Then you remove values which are below, like first quartile minus 1.5 times IQR, or the values which are above third quartile plus 1.5 times IQR. The key exam point, IQR is far more robust for skewed distributions because it doesn't assume normality. The standard deviation method can be misleading when your data is heavily skewed. In Spark, you apply these bounds using the dot filter method on your data frame. And an important practical note is that always examine outliers before removing them. Sometimes they might be legitimate data points and not the errors. Now let's talk about creating visualizations. The exam tests which visualization fits each type of feature and the comparison. For categorical features, use bar charts, count plots, and pie charts. These show the distribution of the categories. For continuous features, use histograms, box plots, or density plots. These show you the shape of your distribution of your data. Databricks notebooks provide a built-in display function that creates interactive charts directly from your data frames. You can also use matplotlib, Seaborn, or Plotly. All of these work in Databricks notebooks. For comparing features, here are the rules. Two categorical features, always use a stacked bar charts or heat map of the crosstabs. For comparing two continuous features, use a scatter plot or correlation heat maps. These are the appropriate methods the exam outline references, if you'll see to it. Now let's tackle the missing values, encoding and transformations. This is where the exam sets its trickiest traps. Imputing missing values, mean versus median versus mode. This is actually directly tested on the exam. It's Also there in one of the sample questions, the question asks, a data scientist needs to impute missing values in a continuous feature with the least effort but correct results. What should they do? The answer is not use the mean, even though the mean is the most common default. The answer is not use sklearn simple imputer, which automatically selects the best method because simple imputer does not auto select. It uses whatever strategy you explicitly tell it to use. The correct answer is examine the distribution of the values first and then select the appropriate imputation. Here is the decision framework, right? Mean works for symmetric distribution without extreme outliers. Median is better for skewed distributions or when outliers are present because the median isn't pulled by the extreme values the way mean actually gets pulled. Mode is useful for categorical features or highly discrete data. The trap is assuming the mean is always correct for continuous columns. It's actually not. If the distribution is skewed, mean will give you a biased imputation. Always look at the data distribution first. Now let's talk about one-hot encoding for categorical features. One-hot encoding converts each category into a separate binary column, a column of zeros and ones. The exam asks two questions about this. First, when is it appropriate? It is appropriate for tree-based models, linear models, and neural networks. Most standard ML algorithms work well with one-hot encoded features. The second point is when it is not appropriate. When the feature has high cardinality, meaning many unique values. If a feature has thousands of unique categories, one-hot encoding will create thousands new columns, causing a dimensionality explosion that hurts your model performance and increases the training time as well. It's not appropriate for ordinal features. Features where categories have a meaningful order, like low, medium, and high. One-hot encoding actually destroys that ordering. You should use ordinal encoding instead, which maps the categories to ordered integers. In Spark, you change string indexer and one-hot encoder in a pipeline. In scikit-learn, use one-hot encoder or pandas get dummies. You should know both these approaches for the exam. Now let's talk about log scale transformation. Log transformation is one of the most important data preprocessing techniques. You apply a log transformation when your data is right skewed, meaning it has a long tail of large values. This is common with features like prices, incomes, counts, page views, and population data. The transformation actually compresses large values and spreads out the small ones, making the distribution more like a normal one. This helps linear models which assume normally distributed features. The formula is log of the feature plus 1. We add 1 to handle 0 values since log of 0 is undefined. Now here is a critical exam point, and this appears in the exam outline explicitly. If you log transform your target variables during training, you must exponentiate your predictions before calculating evaluation metrics. Remember, you must exponentiate your predictions before calculating evaluation metrics. Think about it. If you trained a model to predict log of price, your raw predictions are in log scale. Computing RMSE on a log scale predictions versus actual dollar prices is meaningless. You need to apply exponential to the power of prediction to convert it back to the original scale before computing RMSE or for that matter any other metric. This is the direct exam question, so please don't miss it. So what are the key takeaways from this section? Here are data processing essentials. Use df.summary for stats with quartiles or dbutils.data.summarize for visual profiling. IQR is more robust than standard deviation for outlier removal, especially when you have skewed data. Always examine the distribution before choosing a imputation strategy. Don't default to the mean always. One-hot encoding works for most of the models, but not for the features where you have high cardinality. And I will say it one more time. Exponentiate log transformed predictions before computing evaluation metrics. This will always show up on the exam. This covers section 2. Next is video 5, where we will talk about model development. We'll cover algorithm selection, hyperparameter tuning with hyperopt and grid search, cross-validation, evaluation metrics, and the bias variance trade-off. It is the biggest section in terms of content volume. So I will see you there. Thank you for your time.